I wanted to do some examples from section 4.2. These involve solving these system of equations by substitution. What I've done is I've grabbed an example here, 2y plus 1 equals x, and 3x plus 10y equals negative 1, and I've had the computer graph them. And if you'll see, the intersection point of these two lines does not happen at a good spot. It doesn't happen at a corner point. So if you were to graph these and try to guess what the answer was, most likely, unless your graph was absolutely perfect, you wouldn't be able to discover this point by graphing. So I want to show you a method that will figure out that point, and that is by substitution. So what I'm going to do to solve this, let me take and copy it and rewrite it again and show you what we do. Alright, now if you'll notice here, in the first equation, x is all by itself. So what I'm going to do is take this expression for x and substitute it into the second equation. So we're going to substitute x equals 2y plus 1 into the second equation. So let's go ahead and do that. So I'll have 3, but instead of the x, I'll replace it with 2y plus 1. And then you had plus 10y, and that equals negative 1. So I'm going to then solve for y. Once I figure out y, I'll go back to this first equation to figure out the x value. So as you would normally do, I'm going to distribute the 3 to both parts of this expression, and I'll get 6y plus 3 plus 10y equals negative 1. Now let me combine my y's. 16y plus 3 equals negative 1. Subtract 3 from both sides. So you get 16y equals negative 4. Then I'll divide by 16. If I simplify that, that equals negative 1/4. So I have the y value. Now to get the x value, I will go back to x equals 2y plus 1. And I will replace y with the negative 1/4 that I just found. And now in this expression here, or this equation, the 2 goes into 4 once. If I put the 2 as being 2 over 1, then I know I can cancel this. I'll be left with a 2 here and a 1 here. And I'll see then that I have negative 1/2 plus 1. Not quite done yet. I'll change the 1 into a 2 over 2. And it looks to me like I'll end up with x equals 1/2. So combined with my y equals negative 1/4, my answer is the point 1/2, comma, negative 1/4. So when you write your answer, make sure you list both the x and the y value, and we typically put it in this format to indicate that it is a point of intersection between the two lines. Let me go back and show you that this actually was. Negative 1/2 has the decimal 0.5, and negative 1/4 has the decimal 0.25. If we go back to the graph, there it is, x equals 0.5 or 1/2, and y equals negative 0.25 or negative 1/4. So let me do a few examples of this type, illustrating how you'll substitute something into something else. Even though I did an example, I will call this one example 1. And I'll grab things directly from your textbook. In this problem here, I have number 52 from the textbook. You can see that I don't have anything explicitly being alone, but I do have a lot of fractions. What I would probably do in a problem like this, let me grab the first equation, x over 4 plus y equals 1/4. And the other one, y over 2 plus 11 over 20 equals x over 10. In order to clear out the fractions from the first equation, I'm going to multiply it by 4. Then when you multiply it through to each and every piece, the 4's will cancel, and this equation will turn into x, because 4 and x over 4, those 4's cancel, and you'll have just an x. Then you'll have 4y, and then 4 times 1/4 will equal 1. On the bottom here, I'm going to multiply this by 20. 20 is the LCD of all these fractions. And when I do that, the 2 goes into 20 10 times. I'll have a 10y plus 20 will cancel with the 20 here. Remember, you're doing this distributive, all three parts. 20 times 11 over 20 will be 11. And on the right-hand side, when I multiply 20 to x over 10, I'll get 2x. Now, we've got to figure out something to substitute into something else. I think the best idea here is if I take the first equation, if I start with x plus 4y equals 1, I can easily get x by itself by subtracting off the 4y. Then now what you have to do next is, if you use one equation to find one of the unknowns by itself, in this case x, then I can't plug it back into the same equation or I'll just get a 0 equals 0 situation. What I need to do is take this and plug it into the second equation. So let's do that. So my second equation becomes 10y plus 11 equals 2 times 1 minus 4y. You see, the x has been replaced by 1 minus 4y. Now let me go ahead and solve this as I normally would any equation. I will do nothing to the left side until I've simplified the right, so I will do a distributive property here, and I'll get 2 minus 8y. And now the game is like normal. I'm going to try to get y by itself, so I will add 8y to both sides. And then I will have 18y plus 11 equals 2. Then I'll subtract 11 from both sides, and I'll get 18y equals negative 9. And then I'll divide by 18. And I'll get y equals negative 1/2. That's what happens when you simplify 9 over 18. So I have half of an answer so far. I need to go back and figure out x. And this is when you use this equation here, x equals 1 minus 4y. Let me grab it and copy it and put it down by where I figured out the y value. Now we're ready to plug in that negative 1/2. X equals 1 minus 4. I'll put negative 1/2 in parentheses. 4 times 1/2 is 2. This negative and this negative will cancel. And I'll have x equals 1 plus 2, or 3. X is equal to 3. So combined with the y equals negative 1/2, my answer is 3. You always put the x first and then the y value. And you're all done. For my next example, I grabbed number 58 from the textbook. Here they've decided to use s and t instead of x and y. With this in mind, it really doesn't matter what the letters are, of course, but what you want to do in this process of substituting, you want to look for which of the equations might make it easier to solve for an unknown all by itself. If I look through this, no matter what I do, I'm going to have to do some sort of dividing to get s or t by itself in the first equation. The second equation, though, makes it pretty clear to me that I could rewrite this. If I subtracted 2s, I could get t equals negative 2s. And then I can take that, remember you have to plug it into the other equation, so let me take this t equals negative 2s and plug it into the first equation. So my 5s plus 10t equals 3. I can rewrite it as 5s plus 10 times negative 2s equals 3. So the substitution has been done. Let me go ahead and solve then for s. So 5s minus 20s equals 3. So I have negative 17s equals 3. All right, right here I've made a mistake and I want to fix it. It's not negative 17s, like right there. It is actually negative 15s, and that is equal to 3. And then I'm going to divide by negative 15 to get s equals negative 3 over 15, which is the same as negative 1 over 5. Now you can scroll back up and try to discover what t was. Here we have t equals negative 2s. Here we have t equals negative 2s. So let me go ahead and put it in here. T equals negative 2, and then instead of an s, I'll put the negative 1 over 5. And so you get an answer for t is 2 over 5. So my answer then is going to be, put the s value first, negative 1/5, comma 2/5. All right, in this example, we see that y is solved in terms of x. If I were to replace y with negative x over 2, I will have a fraction to deal with. But I will go ahead and do it since the y is already solved for. So what I'm going to do is take this equation, the first equation, and I'm going to substitute it into the second equation. So we're going to substitute y equal negative x over 2 into the second equation. And so what will I get? The second equation will be 2x minus 3. Let me go ahead and replace y with negative x over 2. And that's equal to negative 7. Then notice, once again, I'll think of this as 3 over 1. The negatives will cancel here, and I'll get 2x plus 3x over 2, and that will equal negative 7. Now it's at this stage that I'm going to multiply everything by 2 just to eliminate the fraction. And when you do that, make sure you multiply to each and every piece. Let's see, so we get 4x. Notice that the 2 will cancel. The whole reason for doing this was so that it would cancel the 2 down here. So for this next piece, I'll get plus 3x. And on the other side, I will get negative 14. Let me combine my x's to give me 7x equals negative 14. And then I'll divide by 7 to get x equals negative 2. And I'll scroll back up to determine what y was equal to. Y is equal to negative x over 2. And so when I put the x in its place, the negatives will cancel. I will get 2 over 2, and that will equal 1. So my answer is negative 2 comma 1. For my next example, The only thing that looks close to being by itself is this y that's down here. So I am going to rewrite this down here. I'm going to subtract 5 from both sides. That will give me negative y equals negative 3x minus 5. Now I don't want to plug in negative y, although this negative here makes it so I might be able to do that, but I'm not going to do that. Instead, I am going to divide everything by negative 1. And what that will do will tell me that y equals 3x plus 5. This isn't the only way to do it. I could have done something like added y to both sides and then added 3x, and I would have ended up with the same thing. But now take that and plug it into the second equation. Actually, plug it into the first equation. So my 5x minus 2y equals negative 7 turns into 5x minus 2. And now let me go ahead and replace y with 3x plus 5. And I'll solve for x like normal. So I have 5x. Don't forget to distribute the negative 2 to both pieces. So negative 6x minus 10 equals negative 7. And then that will give me negative x minus 10 equals negative 7. Let me add 10 to both sides to get negative x equals 3. And then divide by negative 1 to get x equals negative 3. That's half of my answer. Now I've got to go and grab the equation that I had for y back, and I will replace x with negative 3 now, so I get y equals 3 times negative 3 plus 5. 3 times negative 3 is negative 9. So y equals negative 4. So I have my answer. It is a good idea to keep in mind that if you would have graphed this would have been a good candidate for graphing because the niceness of the answer. It would have ended up on a corner spot on the graph. In problem 66, we are given a much more complicated expression. Here, even though y is seemingly close to being alone, it's not, because there's a y over there as well. Now, we'll see how amenable you are to this type of a substitution, but I will rewrite this second equation as 3 times x minus 2 equals y. How did I get that y? I added 2y to both sides of this equation. So in fact, I do have y by itself. You can multiply through if you want, but I don't see a reason to do it. What I'm going to do now is take this and plug it into, or substitute, into the first equation. And let's see what happens. So I'm going to replace this y up here with this expression. So I get 4 times x minus 2 equals 19 minus 5, and then the y will be replaced with 3 times x minus 2. Now I'm not going to do anything fancy, although I could do some nifty stuff with the x minus 2 being in that spot, but I will not. Let me rewrite this equation as 19 minus 15 times x minus 2, and the other side as 4 times x minus 2. Now I'll go ahead and distribute as needed in order to try to get x by itself. All right, so I get 4x minus 8 equals 19 plus 30 will give me 49 minus 15x. Now I'll go ahead and add 15x to both sides. So I get 19x minus 8 equals 49. I will add 8 to both sides. Now I get 19x equals 57. I'll divide by 19, and I will get x equals 3. Now let me go find out what y was equal to and replace my x value. So in this equation, I will replace the x with 3, so I get 3 times 3 minus 2 equals y. 3 minus 2 is equal to 1, so it looks like 3 equals y as well. So my answer is 3, 3. Another one that could have been solved by graphing. As I'm doing these examples, you might find it useful to pause the video and try to do the problem yourself and then see how it works out compared to what I did. Here, x is alone in each one of these. If that's the case, if I take the second equation, x equals y minus 6, I can actually take this whole thing here and plug it in for x. So instead of x on that side, I'll put my 1/2 y plus 2, and on the other side I have y minus 6. So that was a super simple substitution. These you just basically set equal to each other and you're done. Well, not quite done, but in order to solve this, I will do as I normally do and multiply everything by 2 to eliminate the fraction. So I'll get y when I do that multiplication, and then when I do this one, I'll get plus 4 equals, then when I do over here, I'll get 2y, and then here, minus 12. And then I think to get y by itself, I'm going to subtract y. So get 4 equals y minus 12. I'll go ahead and add 12 to both sides. So 16 equals y. Now when you plug it back in, you can really plug it into either one of these equations. I think the second equation is the easiest one, so I'm going to use x equals y minus 6 to get my answer for x. And just replace y with 16. Now this is another one that would have worked out well with graphing. However, since our graphs are usually small, 10 and 16 may have been outside of the range of your graph, especially if you're working small. So this shows you that it'll take care of big answers as well. In fact, the graphical method is only used when the answers are good. The substitution method will absolutely work for any type of pair of equations that you have, and you'll always get the right answer. In this example, it looks like it's easiest to get b by itself if I divide the second equation by -2, I can rewrite that as b equals 2a plus 2. And now I'm going to go ahead and plug that into the first equation. So my first equation, a minus 3b equals -1. Let me replace b with 2a plus 2. And go ahead and solve. Remember, when you distribute, the negative goes with it. So I get -6a minus 6 equals -1. I'll combine my a's. I will add 6 to both sides. And then I will divide by -5. Now go ahead and use the second equation to figure out b. b equals 2a plus 2. Replace a with -1. And it looks like b equals -2 plus 2 will equal 0. So this happens on, well, the a and the b are supposed to be like x and y. Not really big deal, but my answer here is -1, 0. Another good one for graphing. All right, in this example, I guess looking at these two equations, probably the easiest thing. I could divide by 5, but then I'm dealing with fractions, and that will be very annoying. Now, it won't be so bad. If I divide by 5 and plug it into the second equation, the 10 will cancel with the 5. Or I can solve for y. I'll tell you what I am going to do. I am going to do what I said. I am going to rewrite that first equation as y minus 1 over 5 equals x. Then I'm going to take that and plug it into the second equation. Because of this 10 here, I have an opportunity for a nice cancellation. So instead of x, I'll have y minus 1 over 5 minus 2y will equal 2. So here, if you think of this as a 10 over 1, again, if that's needed for you, I can cancel that 5, and I can cancel the 10. So then what I'll have is just 2, let me rewrite it here, 2 times y minus 1 minus 2y equals 2. And now, let me go ahead and distribute this through to each piece, and I'll get 2y minus 2 minus 2y equals 2. And you'll notice the two y's cancel out, and I'm left with just negative 2 equals 2, which is a false statement. Once you have a problem where the y's cancel out and you end up with something like this that's false, there is no solution. If you'll recall what that means, graphically, this means we have parallel lines. So something like this is going on. They're never going to intersect each other. And this is what happens when you have parallel lines, is you get some sort of a false statement arriving where the x and y's all just disappear. In this problem here, it's a very complex, complicated, messed up problem. So what I'm going to do is I'm going to do a little simplifying on each of these equations. For the first one for example, I'm going to multiply this 2 through. Remember, you're going to distribute this. And I'll get 6x equals 2y plus 40 plus 5x. In the second equation, I'm going to do the same thing. I'm going to distribute through each of those pieces, and I'll get 5x minus 5 equals 3y plus 4x plus 40. Right now, I don't see a great advantage to doing anything as far as getting extra. Oh, here we are. I see something right here. Look at this. Something has caught my eye. Actually, something has caught my eye in both of them. If you'll notice here, I have this 5x and I have this 6x. If I subtract 5x from both sides of this equation, I will have a single x left. So let me grab that equation. 6x equals 2y plus 40 plus 5x. And you would do this anyways. You'd try to get the x's by itself maybe. So I'll subtract 5x. I'll subtract 5x. And look at this. X equals 2y plus 40. Now I can plug it into the second equation. It's important to note, I wouldn't have seen this little thing that I could do unless I had multiplied it out like I did. You notice too, in the second equation, I had a 4x that I might have subtracted, and I would have been able to get x by itself using that as well. But anyways, let's go to the second equation. 5x minus 5 equals 3y plus 4x plus 40. And let me replace everywhere I see an x with 2y plus 40. So I'll have 5 in parentheses 2y plus 40 minus 5 equals 3y plus 4 times 2y plus 40 plus 40. And now to figure out y, I'm going to start distributing a bunch of stuff. 5 times 2y will give me 10y. 5 times 40 will give me 200. minus 5. On the other side, I have the 3y just sitting there, but then I have to do this part. 4 times 2y will be 8y, plus 160, plus 40. Just check, there's a lot of y's going on here. I want to make sure that I have everything set. 5x minus 5, 3y, 4x plus 40. And now let's go ahead and simplify a little bit. 10y plus 195 equals 11y plus 200. To get y by itself, I think I'll subtract 10y from both sides, and that will be 195 equals y plus 200. Well, this ended up working out very nicely, didn't it? I'll subtract 200 from both sides, and I get negative 5 equals y. Now I got to go back and find where my x was. Where was that at? There it is, all the way up here. Let me go ahead and grab this. And I'll go ahead and replace my y with negative 5. And so x is equal to 30. Negative 10 plus 40 is 30. So another one that would have been difficult as far as graphing, because the 30 probably would have been off of your sheet. So my answer is 30, comma, negative 5. Now in this example, I'm trying to decide whether to get A or B alone. I don't like the looks of B, although there is a 5B in both sides. And I'm not sure how I want to work it. Let's see if you can handle this kind of a trick. I notice that I have a 5B in both of these. So if I go over here, if I simply add A to both sides of this second equation, I get 5B equals A minus 3. And then I can take and plug that right into the first equation. It's got a slot for it. So plug into the first equation. And let's see what happens. So I got my 3a plus 5b equals negative 6. I know that 5b is a minus 3. There, see the plugging? 5b is replaced by a minus 3. And then let's go ahead and solve for a. 4a minus 3 equals negative 6. I will add 3 to both sides. 4a equals negative... Oh, I boo-booed. Let me change this. 4a minus 3, that was equal to negative 6. And now I'll go ahead and add 3. I'll get 4a equals negative 3. I will divide by 4, so I will get a equals negative 3/4. And now I can go back to this equation in order to get my b. So 5b equals a minus 3. I'll go ahead and replace the a with negative 3/4. At this point, I think I would multiply everything by 4. And so don't forget that you have to multiply each and every component by 4. And I'll get 20b equals negative 3, because the 4's will cancel when I do that multiplication. And then 4 times negative 3 again, that one will give me a negative 12. So I have negative 15 equals 20b. Let me divide by 20 to get b equals negative 15 over 20. 5 goes into both the 15 and the 20, so I'll get negative 3/4. So my answer is negative 3/4, comma, negative 3/4. Another one that would have been difficult to do by graphing. All right, in this problem, I see that x is already solved for, and there is an over 8 here, which means that when I take and plug this in for x, the 8's will cancel. Very nice. So I'm simply going to take this equation x equals negative 3/8, and I'm going to replace the x in the second equation with negative 3/8 y. So the second equation then is 8 times negative 3/8 y minus 3y equals 4. And then these 8's can cancel. It looks like I get negative 3y minus 3y equals 4, or negative 6y equals 4. I'll divide by negative 6. Y equals negative 4/6, which is negative 2/3. Now let me go ahead and plug that back into x. X equals negative 3/8 y. I'll replace y with this negative 2/3. Which is particularly nice because there's a lot of canceling that can happen here. For example, the 3's go away. I can even get rid of the negatives. These are replaced by 1's. And then the 2 even goes into 8. So it looks like all I'm left with when all is said and done is 1/4. And so my answer, the x was 1/4, and the y was negative 2/3. In this example, it's pretty clear to me that you would take a, the expression you have in here for a, and plug it into the second equation. So the 2, and in parentheses, I'm going to have a 9 minus 2b where the a was. You see that? Where the a was, 9 minus 2b is in its spot. That equals 13 plus 9 minus 2b again. Let me simplify in this parenthesis. On the right-hand side, the simplifying that I can do is 13 plus the 9 will give me 22. On the right side, I'm not ready to multiply through just yet until I simplify. I have a 9 minus b. Good. All right, and then I will multiply it through to get 18 minus 2b equals 22 minus 2b. Now what happens here when you try to subtract or add 2b to both sides, I end up with 22 equals 18. You ought to know by now that this means that there is no solution, since the letters dropped out and you're left with a false statement. There is no solution. Keep in mind that that means that the lines are parallel lines. There's a lot of stuff going on here. Nothing is quite solved by itself. I think, let's see if I can do a little manipulation here. If I look, well, let me, before I do anything else, if I add a y to both sides here, I'm going to get a 2y, but then I'd have to subtract x's off the other side. So in order to get y by itself, I'm going to have to do a lot of work there. If I want to get x by itself up here, I can subtract the 3x, subtract the y. That seems like a lot of stuff too. Down here, well, it's very difficult to decide who I want to solve for and what. What I'm going to do, to try to make my life a little bit easier, I'm going to rewrite the first equation. The way I'm going to do that is I'm going to take away the 3x minus y from this side and put it over there. So I'm going to subtract a 3x and I'm going to add a y at the same time. So that will give me 3x plus 2y, that equals negative 8. I'm going to do the same thing to the second equation just to try to give myself a handle on what I could possibly do with even getting x or y. So I'm going to subtract 2y, but subtract x also. So I'm going to 2x, I subtract 2y, I get a minus y, and that will equal negative 3. Okay, now it's clear to me what I can get alone. In the second equation, y is practically alone. What I can do with this equation here is I can manipulate it by adding y and adding 3 and rewriting this equation as 2x plus 3 equals y. Now I'm going to go ahead and plug that into the first equation. And let's see what happens. My first equation is 3x plus 2y equals negative 8. I will go ahead and replace y with 2x plus 3. And then I will have 3x multiplied through by the 2. So I have 3x plus 4x plus 6 equals negative 8. Let me combine those x's to get 7x plus 6 equals negative 8. Let me subtract off the 6. 7x equals negative 14. And then divide by 7, and I get x equals negative 2. And then let me go and grab this equation for y to figure out the y value. Then x is negative 2, so I get 2 times negative 2 plus 3 equals y. We have negative 4 plus 3 equals y, and so I get negative 1 equals y. So my answer is negative 2 comma negative 1. Now, I've done a lot of examples in a lot of different ways, but there's still one last example which I need that I don't yet have. And so I'm going to have to try to find one or make one up for my next example. All right, I think this last example will be what I'm looking for. Notice that the a is already solved for, so I'm going to take the a here and plug it into the a for the first equation. So the first equation, 3a plus 6b equals negative 15. I'll replace the a with negative 2b minus 5, so 3 times negative 2b minus 5 plus 6b equals negative 15. And let me go ahead and multiply through. I end up with negative 6b minus 15 plus 6b equals negative 15. And then notice that the 6b's cancel, negative 6b and the positive 6b, and I get negative 15 equals negative 15. Now this is not a no solution situation because this is not a false statement. This is a true statement. Well, this is a little bit different than before. In this case, what happens is since the a dropped out or the b dropped out, whatever, the a would drop out if I did something different. These are the same line. That means they lay right on top of each other. If you went and graphed one of them, you would have that. Then you go and graph the other line, and it would absolutely lay, well, I can't make it do it, but it would absolutely lay right on top of it. What we write for an answer in a situation like this, our answer is infinitely many solutions. The reason why you say infinitely many solutions because every single point on the line is shared by both lines. That means every single point on the line is an answer. So if they were parallel, which technically these are parallel, but being the same line means that they share every single point along the line. So in this case, we have infinitely many solutions. So that's the gist of section 4.2. I hope I've given enough examples to illustrate it.